Thank you, Karina. Again, my name is Sean Connelly. I lead the TIC program, Trusted Internet Connections program at CISA. A little background on myself. I've been supporting the TIC initiative since about 2007 or so. I've also been involved with other CISA programs, including CDM, the Einstein 3 rollout. More recently, I was one of the co-authors of NIST Special Pub 800-207 on Zero Trust. So next slide, please. First thing we're going to do is we're going to ground ourselves in TIC. TIC is the federal government's primary architectural strategy on how to enhance network security across the federal enterprise, meaning the 100 or so federal civilian executive agencies. The last 10 years, the government's primary strategy was towards a legacy castle and moat philosophy. I'll explain that in a little bit. September of 2019, OMB, through the White House, released Memo 1926, updated the TIC initiative. In July of 2020, CISA, in collaboration with a number of partners and stakeholders, released a number of TIC 3 guidance documents that we speak in a moment. But those guidance documents have three themes in them. The first theme is a new security strategy, allowing agencies to explore new opportunities to secure and redefine their perimeters. Oops, back one slide. Flexible architecture allows for a castle and moat strategy that most of us are familiar with, and we'll explore in a few slides. Allows for alternative architectures to define the agency's boundaries and perimeters. And visibility, the situational awareness mission, both for the agency and CISA. So understanding that shift from TIC 1 and TIC 2, from securing a single network boundary to where we are at TIC 3, allowing a distributed secure architecture, a new security strategy, new flexibility, new visibility is the most fundamental change, the updated guidance. Next slide, please. So the guidance documents itself. So there are 5 documents: program guidebook, reference architecture, security capabilities catalog, use cases, and the overlay handbooks. These documents can be grouped in 2 different groups. The guidebook and the architecture, the first 2, we consider those to be strategic or programmatic. And the other documents, the capabilities catalog, the use cases, and what we're doing with overlays, we consider that to be more operational or tactical. This program guidance is additive. We recommend readers start with the program guidebook and end with the overlay handbook when reviewing the guidance to get the most comprehensive understanding of the new program. Next slide, please. And there's the webpage for security, sorry. We'll begin by focusing on the first thing in the new guidance, security. Next slide, please. So TIC 3 is positioned to help agencies with their IT modernization plans. On the right side of the common themes to hear from agencies, vendors, and the greater IT community on TIC. Trust zones, new concept introduced in TIC 3 that we'll talk about in a moment. Zero trust, the continual establishment and reestablishment of confidence in your systems. SASE, edge computing. We'll explore most of these over the next 20 minutes or so. Next slide, please. So protecting networks with trust zones. One of the ideas we introduced in the new guidance is the concept of trust zones. Trust zones is a logical boundary placed around a computing environment. Trust zone concept is intentionally abstract, allowing the agency the flexibility to shrink or expand that zone to properly secure the embedded computing resource. For example, trust zone can be the agency's entire network, as in the old TIC 2 paradigm. Those examples will show the following slides. The trust zones can also be a cloud container, or a branch office, or an application, or an endpoint, or an identity. Ideally, we want to shrink that trust zone down to be as small as possible to limit the attack surface. The TIC guidance allows the agencies to have the flexibility to decide the size and shape of their trust zones. Those 4 blue dots you see in this diagram, the PEPs, policy enforcement points, common industry term that can enforce security policies in and out of those trust zones. So we'll see this diagram a few more times over the next few slides. But with this concept of disparate trust zones, the perimeter can now be anywhere the enterprise needs it to be. Perimeter can be dynamically created and elastic. Perimeter can be policy-based. Perimeter doesn't have to be bound by a network. Next slide, please. Same time, just want to make everyone aware of NIST Special Pub 800-207 Zero Trust. It's always important when discussing Zero Trust to recognize that Zero Trust is more than an architecture. Zero Trust is a philosophy and change in culture that needs to be embraced by the entire organization. I know TJ will talk a little bit more Zero Trust during his presentation. There are 7 tenets in Zero Trust, and those 7 tenets we try to align ourselves as strongly as possible with TIC, including least privilege, access per session, and policy-based, and everything being measured. So again, we embed those same tenets into the TIC philosophies. Next slide, please. So to orientate the audience on this slide, from left to right, we show 3 different architectures. TIC 2 is on the far left, then moving from the macro segmented to a micro segmented environment in the middle, a zero trust environment on the far right. In each architecture, we show 4 resources that we want to protect: agency headquarters, branch office, remote user, and data center. For this slide's perspective, in each of the 3 diagrams, we show a blue shaded area as an area which has been hacked or compromised, an impacted area. On the left is that TIC 2 model, the traditional castle and moat. The area is protected by one large PEP at the top of the zone. If there's a compromise within the perimeter, adversary has the potential for easily maneuvering throughout the entire environment. The middle diagram shows the same resources are protected by segmenting the resources to smaller and more granular trust zones. Instead of one large PEP, the resources are each protected by PEP which can be tailored to their requirements. This blast radius has shrunk to where if one resource is impacted, in this case the agency headquarters, adversary doesn't have the same freedom to move to the other trust zones. Diagram on the far right shows zero trust. The compromise is also against agency HQ, but doesn't impact the other 3 trust zones. You notice the network itself is not represented in the zero trust environment. As mentioned earlier, the network is suspect in a zero trust architecture. Next slide, please. Flexibility. Now we'll focus on the second theme of the new guidance, flexibility. Next slide, please. Let's begin by discussing how the network has evolved. On the left side, we show the traditional traffic flows in the TIC 2 architecture. All the trusted resources are on the bottom of that diagram. Trusted resources, remote user, agency users, agency applications, agency data center. The traffic between each of those resources at the south end of the diagram what's been called the east-west traffic has traditionally been outside the scope of the TIC program. Then the top side of the diagram, we're still on the left one, we have some of the untrusted resources represented: big bad web, public users, and cloud instances. The traffic between the top and the bottom is the north-south traffic patterns that we've been building our security around for the last 20 plus years. But in reality, we know there are a variety of levels of trust and confidence in the resources. Positioning of each resource isn't as easy as deciding who's on the north side and who's on the south side of the data flows. The diagram on the right, some agencies look at the trust they grant for their cloud environments, not as simple as north or south, but somewhere in the middle. We show the cloud environment in the northeast quadrant. Some agencies consider their remote users with a different level of confidence than their on-prem users. So the agency may place remote users in the northwest quadrant. Then when you start to map out all the data flows between the resources, you realize it's not as simple as north and south, east and west. So what have we done? Next slide, please. We've broken that networking compass. The architectural compass that we relied upon for the last 20 years is broken. The focus on labeling traffic into the traditional north or south or east or west corridors are less relevant in today's modern architecture. With TIC 3, we recognize that agencies need a new paradigm to account for the ever-increasing complexities and interconnectedness of agency on-prem, hybrid, multi-cloud environments, while accounting for the needs of both the public and agency users. We recognize agencies need new flexible architectures to support modern computing environments. Next slide, please. So as we begin to see this new flexibility offered in TIC 3, agencies have a new level of discretion of how to create and secure those trust zones in terms of the number of trust zones, dependent on defining what is being protected, the composition of the trust zones, what's inside the trust zone, the interconnectedness of the trust zones, who's talking to who, where the PEPs are located along the path between the trust zones, as well as the security services and countermeasures are within each PEP along the path. Next slide, please. So TIC also enhances that flexibility. We show the flexibility the agency has in choosing a security framework that best suits their needs. We show the 4 resources: agency headquarters, data center, remote user. We saw this slide before from the perspective of a compromised environment. This time, we show the flexibility in positioning the security. On the left, in the TIC 2 model, the primary boundary protections at the top of the diagram. They're traditional TIC. It's not the most flexible of architectures. That's where the enterprise firewalls, web proxies, detection sensors, and other boundary protection mechanisms are based. The middle diagram shows how these same resources are protected by segmenting the resources to smaller, more granular trust zones. Now we're able to position the security closer to the resources themselves, instead of aggregating everything at one access point. The zone can be protected by a PEP that is more tailored and focused on the resources that requires protection. The diagram on the right shows a zero trust environment. Notice the network isn't represented. I mentioned earlier the network is suspect. A lot of the controls in a zero trust environment have an identity focus embedded in them. Identity supports that new flexible model. Identity is becoming the fabric that binds the resources together. Identity is now becoming the network. Next slide, please. Visibility. We'll focus on the third thing in the new guidance, visibility. Next slide, please. We know today's environments are complex and messy. Visibility needs data. Data comes from many disparate areas. With TIC 3, with trust zones and PEPs, with the potential for many more sources of data in the old TIC 2 model. Visibility also should be about context, not only the activity itself. Detection also needs people. People are hard to scale. We're just beginning to see the opportunities that machine learning and artificial intelligence can offer. It shouldn't come as a shock. The attacker doesn't want to be detected. Adversaries are becoming more sophisticated. Attackers are trying to evade network defenses. Next slide, please. So visibility narrative is evolving into two separate camps, monitoring and observability, two different sides of the same visibility coin. Monitoring, that lower left picture, watching the known unknowns, more towards watching a system, watching hundreds or thousands of systems that they're spun up and spun down the cloud. Monitoring tends to be very specific, laser focused. Monitoring tools have tight apertures. In fact, the way we can scale monitoring the cloud can be many tight apertures, thousands of them. Observability, the upper right, watching them for the unknown unknowns. More broad focus, instead of thousands of tiny apertures, one large wide aperture. Looking for the abnormal, but not necessarily knowing what you're looking for. High cardinality, meaning many unique items in the data set. High dimensionality, many different contexts. What does the system look like under normal state? What does the system look like under backup? When's under stress? The benefits of better visibility, increase accuracy, finding that signal in the noise, improve efficiency, focusing on what matters, strengthening collaboration, and ultimately mission resilience. Next slide, please. I want to introduce recognizing where data is being generated in the cloud at the branch office, at data center. Unless that data is moved from where it's created, the data begins to accumulate mass. As the data accrues mass, the data accrues gravity. It's a new term you may be hearing called data gravity. As data is generated, and unless the data is relocated, the data will accumulate mass. As the data's mass grows, it starts to generate gravity. It make more sense to push the services and security to where the data is within the trust zones. In effect, the data's increased mass and gravity is drawing security to it versus moving the data to where the apps and security services are located in the old TIC 2 model. Next slide, please. Same time, SASE, Secure Access Service Edge. CISA is leveraging the SASE philosophy for own services and programs to assist agencies on their IT modernization endeavors. SASE offers three benefits: reduce IT cost and complexities, focusing on pushing security as close to the network and entities as possible, focus on the user experience, and also ideally reducing the risk. Next slide, please. Visibility, same diagram. You move from a macro segmented environment into a micro segmented environment, and we move the PEPs closer to the resources. We need to be aware of how this changed the context of the visibility. The far right, the old TIC 2 model, sits with visibility mainly at the TIC of the PEP, at the top of the diagram. It's becoming extremely difficult to gain proper context. It's also becoming more of a challenge to shuffle the data where the sensors are located. CISAs begin to invert some of our service models, moving towards Gartner SASEs. CISAs begin to push our services, NCPS, also known as Einstein, and CDM out to where the data is generated. The same thing with GSA and their EIS team, how they are inverting their service model and offering new flexibilities for where the data is generated and located. In fact, CISA and GSA is embracing that SASE model by pushing our visibility services to the new edge. Next slide, please. So this is a very heavy on TIC at the top. I'll just admit that straight up, but being selfish, this is a TIC presentation. So this is just how TIC is helping the agency to secure their architectures. At about 12 o'clock, we work with the agencies on TIC pilots. It will be used to develop our use cases and overlays I mentioned earlier. GSA at the same time will leverage these use cases to develop and build out their EIS service packages. At the same time, agencies will be using a number of other raw materials, including FedRAMP, NIST special pubs, OMB memos, and such, to securely build out their environments, to efficiently build out their environments, repeatable environments, predictable environments. So as agencies use these templates to build their environments, now we move down to 4 o'clock. These repeatable environments will be positioned in the landscape for CISA's CDM and NCPS programs to more efficiently monitor and observe these environments. Now, if you move over to 8 o'clock, as the environments are secured, we gain more visibility, better visibility, more predictable visibility. This can feed into agency SOCs along with CISA SOC, better understand the agency's environments. Ultimately, this leads to a more secure.gov. And to be fair, this is an agile loop. So the whole time we'll be updating and repositioning our activities to improve ourselves. Next slide, please. I want to take a minute and mention NCPS, again, operationally known as Einstein. For a long time, Einstein was the primary sensor deployment program for CISA. We were deploying our sensors at the agency's TIC access points. For a long time, the NCPS program was tightly coupled to the TIC program. But as TIC supports a more decentralized architecture, the NCPS program is also moving to support this decentralized environment. NCPS team has released a number of cloud interface reference architectures, Volume 1 and Volume 2. They're available at that URL you see on the screen. These guides dive into how CISA will begin to work with agencies and vendors on how to collect this new type of telemetry. Next slide, please. Future focus. Let's wrap up by talking about what's on the roadmap for TIC. Next slide, please. We'll be focused on new pilots, new overlays, and use cases. Next slide, please. So vendors have started mapping their services to capabilities listed in the security capabilities catalog. Several vendors have started to make these overlays available. Agencies are encouraged to tailor and look at these overlays and help use these overlays to build out their environments. One strong caveat to understand though, the overlays are created and maintained by the vendor. They're not approved, or there's no validation from the CISA team itself. Next slide, please. Same time, use case generation. We have a number of people that work with us when we build out our stakeholders. We have the CISA team on the far left. Same time, we're heavily engaged with OMB and their USDS colleagues. We also channel all our efforts to the Federal CISO Council. And then also we have our partners at GSA, the sponsoring agencies, and the vendors themselves who all work together to build out these use cases. Next slide, please. And how do we build out these use cases? I want to take a moment to walk you through. We use a number of ways to build out these use cases. If you look on the left, you see we have a couple example pilots. We'll work with agencies in the background, learning and distilling lessons learned from their pilots. We'll feed those into our use cases. At the same time, we'll talk to agencies, best of breed, if you will, and listen to where they may already have gone into production. We'll talk to those agencies. Again, we'll distill those lessons learned into our use cases. We'll talk a little bit in another slide about the use cases themselves. Ideally, once these use cases are released, then the agencies are free to interpret and build out what we call reflections of the use case, solution architectures. Next slide, please. So I think we'll wrap up here. I just want to make everyone aware of where we are with all our guidance. We have 4 phases you see represented. Phase 1 is what we released last summer, the program guidebook, RA, the capabilities. That was all released last year. We just released phase 2, which was releasing the final versions of the traditional TIC, the branch office use cases, and I think in December, we released a draft remote user use case. Now we're moving to phase 3. That OMB memo I mentioned at the very beginning. There's a number of other use cases defined in that memo that CISA is still responsible to work with a number of stakeholders to build out. IaaS, SaaS, PaaS, email. At the same time, we are starting to work with some partners on building out some IPv6 guidance for TIC. Once we move past phase 3, then phase 4. Ideally, we're working out some other use cases. Everyone's asking about zero trust. Ideally, we come out with a zero trust use case, an Internet of Things use case, possibly one toward R&D or partner networks, and a couple more. But again, that's all phase 4, and right now we're focused on getting through phase 3. I think that covers it. I'm going to wrap up there. Next slide has some of our contact information. But I think I'm going to pass it over to TJ at this time. Thank you.